Welcome back, everyone. What I've got here is a Russian edition of Popular Mechanics. Sadly, I cannot read Russian, but you don't really need to know how to read Russian to appreciate what's in it. There's a nice 4-page spread right in the middle of this magazine, or closer to the end, of these pretty nice, finely crafted kinetic sculptures that are kind of out of this world and not like anything I've ever seen before. If you've ever heard of Calder, I think his name is Calder, he used to build sculptures that would kind of deceive the eye. One of the most famous ones is a chair that splits itself apart and it kind of runs on a motor. But if you're interested in anything of that nature, you'll love this. This is a sculpture of a hummingbird in flight, and apparently it feeds from a flower. But the gentleman who designed this, and here's a picture of him, is located at the United States of America and was contacted by the Russian arm of Popular Mechanics to do an interview. And he also showed a couple of other objects that he designed and built. This is just a random wall art piece that kind of, when you spin it, it rotates and does all kinds of cool stuff. Now, the gentleman who designed this stuff is standing right next to me, and I'm in his apartment, and I'll let him introduce himself.
Hi guys, I'm Derek Cugger, and I made that thing.
Let's talk about it.
Sure, so this is Colibri. This is a kinetic sculpture of a hummingbird. The most common question that I get about this is, besides how did you make it, is where did you get the idea for it and how did you come up with it? And it ended up being just kind of this lunchtime conversation between a coworker and I, and we were going back and forth about different mechanisms and things that I could make for my next project, you know, different clocks or wall-mounted sculptures. And I was kind of thinking, what if I sort of step out of my box and instead of doing these, you know, abstract mechanical things, what if I did something that was, you know, a little bit more complicated and something that was based on nature? And I remember just saying to him, what if I did something organic, like a hummingbird flying in slow motion? And I remember him saying, how the hell are you going to do that? And my response was just, I have no idea. So with that, I went home and I scoured YouTube for hours and hours and hours and just watched tons of videos of hummingbirds flying, and eventually decided, okay, I know the movements that I want, I know what I want it to look like. And so I started animating it, and based on that animation, I was then able to start coming up with some mechanisms that could drive the motions. And then once I had a basic idea of how the mechanisms could work, I sort of started the nitty-gritty engineering of it. And eventually this came out.
So, I'm sorry.
I was going to say, to my surprise, almost everything on this is from the original design. So people say, how many prototype iterations did you go through? And the answer is, this is the first and only prototype. And the only two things on here that weren't part of the original design are the counterweight over in the back here, and also these magnetic hinges on the wings. So I originally had very simple pins that were slipped into tubes, and what was happening was, because of my tolerance buildup and because of the forces that are applied to that area, the pins were coming out of the tubes. Now the reason I couldn't put some sort of a fastener on there is because this part on the right side would interfere, so there's absolutely no room over here. And as this part swings up, it gets ridiculously close to the head as well. So there's just no room on either side of these two links to put anything. So I tried pressing some magnets into there, and they stuck, and they worked as a pivot, and everything was great.
Very, very amazing. So you must have years of education in mechanical engineering, no?
I did 2 years of mechanical engineering and decided that I absolutely hated all the math and theory, and I wanted to design stuff. So I ended up switching to a major that basically involves graphic design and animation. And now, which is kind of cool, I kind of do a mix of all of those things. So I do a little bit of engineering, a little bit of animation, and a little bit of design.
It's pretty cool how you actually melded those fields together. I mean, when you think about it, animation is really just, you know, another form of mechanical engineering, and well, maybe not. I just made that up. It sounded nice, didn't it?
It did. I mean, you can use animation as a mechanical engineering tool, which is something that most engineers don't do. And for making a sculpture like this, it was I couldn't have done it without the animation portion.
Very cool.
So I guess I can kind of walk through what all this stuff on here does. So I guess we can start off by just, looking. Here's the input.
Okay.
There's a gear here, and that gear turns all these other gears coming up the train here. So there is this one small one, and then there are 3 larger gears, and then another small one at the top. So what this wants to do is, I wanted to make a sculpture where the wings are moving, where the head and body can articulate independently, and where the tail can also move. So starting just at the basics of, okay, I want this thing to move back and forth. I want it to fly into the flower and fly out. So that's just a very simple pivot about this axis. So this can move back and forth. And on its own, it doesn't look very impressive. It's like, okay, I see the thing tilting, but nothing else happens. Well, you have to have all the other pieces moving in order for that to really come to life. But the way these pieces in here work these are called hypocycloid reducers. And as this gear turns, there's an eccentric cam in here that spins around. And as that cam spins, this flower-shaped gear sort of walks along these pins here. So as it turns, it doesn't turn like a gear where it just stays stationary in place. It'll actually it'll rotate through those pins, and then it'll come out, and then it'll rotate through the next set of pins, and then it'll rotate through the next. And that motion creates this eccentric wobbling for 4 holes that are also in that flower-shaped gear. And then these 4 pins on this outer cam are riding in that hole. So that ends up creating a 4-to-1 reduction. So for every 4 times this gear spins, this output cam here will spin 1 time with 4 times the force of the input gear. So this part, again, will control the motion back and forth. This second cam controls the tail, and this part's kind of interesting. So the tail, the best view of it is sort of up from above, and what happens when this cam lifts, the tail not only moves up and down, but when it moves far enough, it will flare outward. And the way this works is, you can see there's this stationary gear here, and this is attached to the body. And as this cam pushes this arm up, you can see this gear stays stationary, and then this one rides up along it. From the side, you can see that there is a rack in here. So as that gear rides up, this rack pulls forward. And as the rack pulls forward, the pin in the back pulls forward. And as that happens, you can see that there are 5 independent cam slots on each one of these tail feathers. So as this pulls forward, the pin stays in the slot. Since the tail is constrained at this pivot point, this feather is going to move in order to accommodate that pin. So then this top cam, there's actually 2 of them stacked side by side. The front one controls the body motion, so you can see I can control the tilt of the body by moving that one. And then the top one can control the rotation of the head. And unfortunately I can't rotate the wings manually, so with that, I'll plug it in, and you can see how it works. So you can see there's a 4-bar linkage here that controls the wings. This was a very tricky thing to figure out. I looked on YouTube for hours and hours to try and find some sort of a mechanism to control the wings, and there was just absolutely nothing. And what I noticed was, as I would animate the wings, I noticed that if I constrained a link here to the wings, it would create this sort of kidney bean shape. And I remember seeing that same kidney bean shape in a 4-bar linkage synthesis. So I went back and did some research on 4 bars and realized that it could create a shape very, very similar to one that I wanted. So with that, I did a little bit of optimization and eventually got the wings to move how they should.
Very amazing. It's one of those sculptures you just sort of have to watch to appreciate it and kind of examine, I find, each component independently and just sort of So if I wanted one of these, how would I obtain one?
So if you want one of these things, the thing that you can do is you can purchase the plans, which this was an entire project in itself. After creating the sculpture, was documenting it. So this entire thing is documented in about 77 pages. So I start off with a letter to the builder, kind of just going over sort of some of the things we talked about, how the idea came to life. And then I jump right into how to build it. So there's a basic process for what to do. I list out all the tools that are required, all the tools that are recommended to make your life easier. These aren't necessarily needed, but they're certainly convenient to have. I go through how to read all the instructions, and then I give tips for how to work with some of the things that you wouldn't necessarily think of. So like, for example, the tail tuning, how to make sure that it's running right, how to figure out where the friction in the system is, how to figure out where to weight the thing to make it run properly, how to adjust the gear timing if some of the cams are off when you put it together, because some of the pieces are very, very explicit in the orientations that they need to be. I also have a complete parts list. There are about 400 parts in this sculpture, which may seem a little daunting, but most of them are fasteners and things like that. There are about 100 different wood parts in there though. So this also, I list out all the hardware, and if you live in the United States and can order from McMaster, I list out all the part numbers for everything you can possibly order, so you don't actually have to go searching for anything. It's all listed right there. All the metal parts, all the sizes and everything are listed out. Then once you get through making all the metal pieces, there are full-scale patterns for every single wood part. Every one is labeled, everything has a hole call out, everything has a thickness call out, and there's also a scale on the top of each page for the patterns to ensure that they've been printed to the correct size. So we get through those, and there are a lot of them, and then we get into the assembly after many, many more patterns. So the assembly is broken down into sub-assemblies, and then the top level. So you can see every single step is written out, every single piece is labeled. So it goes through about 40 or so sub-assemblies. Again, you can see very detailed step-by-step how to put every single piece together. And then after that comes the top level assembly. So you start with one piece, attach all the parts, it ends up looking like that. Now this piece is the starting point for the next part of the assembly. So it's very Lego style of, you build something, you attach a whole bunch of stuff, now you take that and you add more to it, and you add more to it, and you add more to it. Until eventually you get something that starts to resemble a hummingbird. You see, for each step you get closer and closer. And eventually you have everything done.
In terms of time, how much time would you say it would take me to build one of these? If
Well,
I had the optimal tools.
It's one of those things where it really depends on your skill level. So for me to design this, build it, test it, tweak it, get it running right, document it, update the website, everything in total was roughly 700 hours. The actual build time on this, I'd say I probably spent about 150 to 200 hours actually building it. It depends whether you have a CNC machine or you're doing it by hand. I know that several people have sent me photos that have been done by hand, and it's taken them a little bit longer, but the people with CNC machines, it's typically around 150 hours going from start to finish.
So as someone with moderate skills, 150 hours. Yep. And in terms of cost, now the plans, you certainly don't give those away.
The plans I charge $100 for, or $99, again, just because this was a 700-hour project. And also, I don't know of anything else like this available. So I figure, you know what, I spent a lot of time on this. I think it's worth $99. And from the people who have bought the plans and then sent me comments about them, almost everyone has said it is a bargain with the amount of detail that's in there. So the plans are $100, and rough cost for all the materials that are needed, I believe, is about $300.
That's not bad.
So it's from start to finish, it's roughly a $400 build.
And that's something that would entertain the family or office staff or whatever, wherever it happens to be displayed for years to come. I mean, that's an incredible and unique sculpture. Just absolutely stunning. Well, thanks again, Derek, for your time, and hopefully we'll see a lot more of these come out of your shop.
That's the plan.
All right. As we mentioned earlier, Derek also designed this particular sculpture, which I'm going to have him talk about because I'll just do do it more harm than good. Go ahead.
Sure. So this is, I call this one Kinestrata, which the roots mean motion layers. So this is a marble machine that has roughly 400 parts in it, and it's weight driven. So there's a large stainless steel weight over on the side here that gets lifted up, and as that gets lifted by this little puller right here, this little pull comes down, and then that drives a clock escapement back here, which allows these 3 wheels to move at a very uniform rate. And those wheels, you'll notice, have a whole bunch of marbles inlaid in them. And as those marbles get to the top, they roll down 4 different tracks. So I will pull the weight up and let this run.
So what's happening is these marbles are being drawn up from one wheel to the other.
Yep, up at the top, and then you can see on the top there's a layer of wood that goes in between the wheel that allows them to drop off.
And depending on which path they take, they hit a different chime every time, right?
You can see there's these different T-shaped pieces in here, 2 here, and those are what determine the track. So each time a ball goes down, they switch.
That's just awesome. Now, do you also sell plans for this?
I do.
You do?
Yep. Kinestrata is, I believe, $69.
$69, and where can I find it?
DerekHugger.com.
All right. Thanks again.